Okay, so you probably remember back in intermediate algebra or even a high school algebra class being told that you can't graph complex numbers. And I know I've said that many times in intermediate algebra classes. I've said that to students. It turns out it's not entirely true. Actually, we can graph complex numbers, right? And the way we do that, and let's do this with an example. If I take the number 4 plus 4i, I would graph this at the point 4 comma 4. Right, so I'd go over 4 of 4, and I would get this point here. So what we're doing is we're letting the x-axis be what's called the real axis, and we're letting the y-axis be what's called the imaginary axis, and we get this point. Okay, so what I want to do now, take this point, I want to rewrite this point in its polar form. Right? I want to convert this to an r and a theta. Right? And to do that, you can pause it if you like, if you need one little practice, right? Do that conversion. R is going to be the square root of 4 squared plus 4 squared. That's the square root of 32, which is 4 times the square root of 2. And theta is the inverse tangent of 4 divided by 4. That's 1, right? So this is pi over 4, or 45 degrees. Either way will work just fine. Okay, so if this point is 4 square root of 2 cosine pi over 4, comma 4 square root of 2 sine pi over 4, then again, right, remember how I'm converting back and forth between these complex numbers here. The x-coordinate is the real part, and the y-coordinate is the imaginary part. So that means my point 4 plus 4i is equal to 4 square root of 2 cosine pi over 4 plus 4 square root of 2i sine pi over 4. Or I could simplify this a little bit. I could factor out that 4 square root of 2. 4 square root of 2 cosine pi over 4 plus I sine pi over 4. And that is the polar form of this complex number. Right? So, and I've written that out here. Right? If z is equal to this complex number, then this number is equal to r cosine theta plus r sine theta times I, or you can factor out that r, and you're left with this. Now, this last notation, the way I would just read it literally the way it is, r cis theta. This is how I learned this like 35 years ago. I don't see this really in textbooks anymore, and it's a little unfortunate because it actually makes writing some of the things we're going to be doing throughout the rest of this series of lectures a whole lot easier if we can just combine that cosine plus I sine theta into one nice, neat, complex expression. All right, so I want to do a little back and forth here, right? I have a complex number, and it's written in its polar form, and I want to rewrite this in the rectangular form. All right, well, this really is just a matter of writing this out. This is 3 cosine 120 degrees plus I sine 120 degrees. Cosine of 120 degrees, that's negative 1/2. So this is 3 times negative 1/2 plus the square root of 3 over 2. That's the sine of 120 degrees, I. And then distribute the 3 into here. Minus 3/2 plus 3 square root of 3 over 2, I. That is the equivalent rectangular version of this number. Okay, so you kind of saw me do a conversion from rectangular to polar back at the very beginning, right? So why don't you pause the presentation, see if you can't convert this number to the equivalent polar form. You're going to find the r and theta values to do that. Okay, so r is the square root of negative 4 squared plus negative 9 squared. And my calculator, we're going to be doing a lot of going to decimals with these. So my calculator tells me this is 9.849. And theta is the inverse tangent of negative 9 divided by negative 4. Now remember, you have to be a little careful here, right? When I do this in my calculator, it tells me it's 66 degrees. Well, no, it's not. That's in the first quadrant, and my point is in the third quadrant. So I need a third quadrant angle that has the same tangent, and that's easy to find. Just add 180 degrees. If I had an 180 degrees, this comes out to 246.038 degrees, and that gives me my polar form. Right? This number is equal to 9.849 cosine 246.038 plus I sine 246.038. Or you can just go to the streamline, right? My final notation, you can make this 9.849 cis 246.038 degrees. And that's it, right? That's the polar form of this number. Okay, so what's next? So far, this has just been a kind of interesting exercise. We can actually use this to do some really interesting things, some really useful things, much more quickly than we could before. We're going to use it to do arithmetic with complex numbers, right? And you kind of know how to do that already. But like I said, first this is going to speed up some of the calculations we already could have done by hand, and it's going to let us do some more calculations, like finding the roots of a complex number that we couldn't do before.